watching this video, it means that you missed a class. So what you should know is that up until now, what we've been doing is finishing the lab and then on Schoology going through the practice with flashcards. Flashcards that are in the thing that says practice, whatever. You get it. But now let's try. We're going to try drawing some graphs. Can you draw a position graph with positive velocity and negative acceleration? Tiernan! What would a velocity? Oh, sorry. Number one, position graph. Position graph with positive velocity and negative acceleration. It's going to be a position graph. So a position graph that has positive. How do we know the position graph has positive velocity? What tells us a position graph is positive velocity? No, that's a velocity graph has positive velocity if it's above the x-axis. How does a position graph? How do we look at a position graph and be like, oh, that's positive velocity?
The slope is increasing.
No, the slope is no. The slope is positive. See the difference between slope is increasing, slope is positive?
Yeah.
Right? It's a subtle thing, but it's really important. Slope is positive means slope is increasing means So we want a position graph, right? This is positive velocity. So we have to have a positive slope to the position graph. What does it mean to have negative acceleration? What's the line in the middle there? Oh, so a position graph should have, for our things, yeah, can I use this for a second? So just generically speaking, our position graphs are going to look like this, and our velocity graphs are going to look like this. This is just the shorthand that we're using. So position for us, like with our lab setup, there's no way to get on the other side of the detector, so it always looks like that. So how do we? So we need a position graph that has positive velocity. So we have to have positive slope here. How do we show positive slope but also have negative acceleration? What? Explain yourself. help Tiernan, but also can you explain the thing you're thinking? You're waving your hand. It's great. I like it. Let me make a suggestion. This is a hard. So, Tiernan, thank you for playing. I'm not kicking you out. I'm just saying, I mean that in the sense that this is, I've thrown you into the deep end hard here. It is really hard until you've done a little bit more calculus. After you've done a little more calculus, you're like, oh, that's it. But it is really hard until you've done a little bit more calculus to look at a position graph and think acceleration. Until you get to that place, I'm going to make a suggestion that over on the side, before you make this drawing, make a velocity graph. What's a velocity graph with positive velocity and negative acceleration? Can you just draw that on the side? Positive velocity, negative acceleration. No, that has positive acceleration. How do we know that has positive acceleration? Because it's positive slope. Remember that acceleration is a slope of the velocity. So that is going to be positive velocity, and it's got negative slope, so negative acceleration. Absolutely. In our lab, we only have linear velocities for reasons that we'll talk about in a little bit. So can you make that have negative, positive velocity, negative slope, and be linear? Beautiful. Now the question is, what's the position graph look like for that? Why?
That has positive velocity and slope is decreasing.
Excellent. Well done, well done. Nice to on there. Folks following and thinking here? Sweet. Number 2. Andy. Come on down. Why? Come on, Dave. Go up. Number 2, what do we have? You draw a velocity graph. There's negative displacement, positive acceleration.
So I got so far.
Okay, that's awesome. That's awesome, right? Yep, thank you, thank you. Splendid. So
negative displacement, so it's getting further from the sensor. So
what does displacement mean?
yeah,
No.
it's like how far it is from the starting point.
Yes,
With direction.
So it's x final minus x initial.
So it's going down.
Doesn't mean it's going down.
So
What does it mean? How do we know? Feel free to, like, you can phone a friend, all right? But all I care about is that we talk about why.
It's going like towards the sensor.
well, it's just going towards this axis, right? Is that what you mean?
How do we know on a velocity graph it's going toward the sensor? Just speak freely. You don't have to raise your hands. Just help.
Yeah, that's what I'm saying.
So on a position graph, so here's the thing. Yes, this is going toward the axis, but that's not because it's not because it has negative displacement.
And the acceleration is above 0.
First of all, let's talk about that. What does positive acceleration mean for this graph? No.
The speed is saying
It's the slope. So we can have positive slope, but not have increasing speed.
so it's
Does that make sense? Yeah. So So can you draw us just a bunch of different linear things that have positive slope? There's one. Awesome. There's another one. Splendid.
linear.
Yeah.
Um,
Great. Can you go one that doesn't go into the positive zone? Right. We've got one that's all positive, 2 that are positive and negative. Can you draw us one that's all negative? Great. All right. So all of those have positive acceleration. Right?
So would it be like one like this?
Why?
Because it's going towards the 0. So it's
How do you know, when you say towards the 0, you're talking about cart going towards the sensor or graph going towards the time axis?
the cart going towards the center.
Yes. How do you know?
Because like it's going from like farther away, like it started further.
That's not a
Oh,
graph
isn't
of further away. Remember, this is a velocity graph. You guys are doing really awesome, by the way.
Like, can I erase the other one?
Yeah, you can erase anything you want.
So it's this one.
Yes, it's this one. So positive acceleration, positive slope. How do we know this has negative displacement? I can think of a number of different ways of thinking about that. Yeah. No. So remember that.
Well, negative displacement could be like if you started your cart like on the opposite side of the sensor and moved it towards. Right?
So all negative displacement just means we get closer to the sensor. It means the initial position means the initial position is a bigger number than the final position.
Yeah. So
if we have a detector here. If we are here and we go boop, right? That's negative displacement because we end up closer.
even if you just went that way too, right? You don't have
Absolutely.
To, like,
Yeah, I was just making it
okay.
extra complicated.
Oh, so if like the graph gets closer to zero, does that mean the
Which graph? No. How do we tell, looking at a velocity graph, if the displacement is zero? Two ways.
It's slowing down. Well, cause
We can have lots of things that are slowing down.
Because it's like.
Yeah. No, because we can have negative displacement where this was speeding up. Here, the simplest thing to do is to be like, the velocity is negative. When is the velocity negative? What does it mean that when it's going toward the detector?
Yeah.
So this is what we're asking about, like, oh, going toward the detector. Negative velocity. So all we mean here is negative displacement just means it happens below here. Let me just add something here. Remember, what else did we say about when we were deriving the kinematics equations? What did we say about displacement and velocity graphs? Remember this? If that area there, that's the displacement. So if that area is down here, that's negative area. That would be true even if we extended this up. Let's say we're up here, right? And we have, so this would also have positive acceleration, right? Because we have this positive slope. But we'd still have negative displacement because, yeah, sure, there's a little bit of positive displacement here, but there's much more negative displacement. Okay, so this would also fit. Cool. Okay. What's the next one? Position graph moving toward the detector with positive acceleration. Hannah, you are on.
Is it okay if I go?
Of course. Position graph moving toward the detector. Bye, I hope it's interesting. Some of those meetings can be so boring. When my last kid applied to college, I remember just going around and doing those tours. I'm sure it's really different for folks under COVID conditions, but it was just like we just marched from one college to another. You sit down in info sessions, and after 2 info sessions, I felt like I could record the info session, and it would be exactly the same no matter what the school was. I was like, ah! Yes, here we go. Position graph of a cart moving toward the detector with positive acceleration.
So we need to like start higher and go down.
That's awesome. I just want to point out that is one of my favorite strategies for drawing a position graph. Is like, we know we have to get closer. We start high and low, and I am a big fan of just being like, I'm going to put a dot up high, and I'm going to put a dot down low, and now all I have to do is figure out how to connect the two. So I'm just like, that's great. Yeah, start high and low. So how do we connect these? What does it mean to have acceleration?
One's that linear.
Okay, so good thing. Number one, can't be linear. Can't be linear. So we have two choices, right? Right? You could be like or which one of those is going to be positive acceleration?
Did you show what they were?
They were or sorry. Start high and low. We could be doing this, or we could be doing this. The question is, which one of those? Sorry, I'm gonna just for video's sake. What I just drew on the board was start high and low. Is it this, or is it this? So how do we decide which one of those has positive acceleration?
Well, first by just estimating your by using your eyes to estimate, we kind of just I kind of just divide the graph into two parts, and then the first part has like a smaller slope, and the second part has a bigger slope, which means it's accelerating for the upper part. And then if you divide the lower part into two parts, the first half has a bigger slope, and the second half has a smaller slope, which makes
Following
it
the argument?
accelerating. Not exactly, but it has it has a negative acceleration.
Like if it's like this, it starts. The slope isn't as steep, but then it gets.
Do me a favor. Draw that. Okay. Now over on the side, why don't you grab another color just so we distinguish it? Over on the side, can you draw the velocity graph for that? The velocity.
Like this.
So starts slow, ends fast, or starts fast, ends slow?
Start slow
So start near zero, start away from zero.
and near it.
Yeah.
Like this.
Nope, that's positive velocity,
Oh.
right? I have no idea what it is. Yeah. Starts slow, ends fast. Is that positive acceleration? No, it is not positive acceleration. So I totally understand what you were saying about dividing this up, but what you were thinking about was speed, not velocity. You were thinking about speed. Speed and velocity are different. So this has zero velocity, and this has negative velocity. So that is negative acceleration, right? Because it's got a negative slope. So we have to get from here to here. Yeah, but we can't have a negative slope. So there's something wrong. So this graph is not okay. What's that velocity graph look like? Is that positive velocity or negative velocity? No. Is this positive velocity? Or negative velocity? It says negative slope. It has to have negative velocity. So this is negative velocity, starts fast and slow. Can you make a negative velocity graph, starts fast and slow? That's positive velocity.
Oh.
Yes. See that? That is negative velocity starts fast and slow, right? Negative velocity starts fast and slow. Positive acceleration. Okay. People say conceptual physics is easy. Conceptual physics is not easy. Thank you. Awesome. Well done. Well done. Woo! Okay. What's next? We got number 4. Number 4. Andrew, you're on. Number 4, a velocity graph. A velocity graph. Ooh. A velocity graph with acceleration positive and displacement 0. Velocity graph with acceleration positive.
Oh.
I know. Velocity graph with acceleration positive and displacement 0. I think, yeah, leave out that bottom axis here. I just think everything's a lot clearer if you
Because
just
that's
have
kind
yeah,
of the
that is the
Yeah.
that's the time axis.
What? Yeah, I know.
Velocity graph, acceleration positive, displacement 0. What do you talk us through your reason?
Well, first, because the acceleration is bigger than 0, so it has to have a positive slope.
Excellent. Velocity's
So
got
this
to
has a positive slope. And then for displacement equals to 0, we have two scenarios. First one is just horizontal line. It's just the x-axis, so it doesn't have it has a displacement, but it's 0.
Good.
Because it doesn't travel in any direction. It just stays there.
Okay.
And then the second scenario is this, which it goes from negative velocity to positive velocity. And then it travels in 2 different directions. So first it travels toward the detector, then it travels away from the detector. So we can just assume, for example, it starts from 5 meters away and to the detector, which is like here. Then it travels to 5 meters away, but then it travels in 2 directions, but it goes back to the original position. So it also has a 0 displacement.
Thoughts? Yeah.
I guess just to make that like thoughts under the area, like under the negative positive, like farther
We
stay.
can't use
Yes.
positive.
Yeah. And so if you're like this, that's it's an awesome sketch. If we were being really careful, we want that symmetrical and have the upper triangle area and the lower triangle area have the same. Thank you for going back to that reasoning. Yes. It's not the angles, it's the area.
Yeah.
Yeah, we can't, but we can. Yeah, there we go. I mean, any excuse for writing Greek letters makes me happy, but
Yeah, it's just
yeah,
like
yeah, cool. Okay, position graph. Now we're looking for a position graph. Somebody read it to me. What's the position graph? You've already gone. Tiny. you have to hit the marker. Sorry. Down at the bottom, that palette. Yeah. Sorry, it's left on the razor.
So if the displacement is 0 on the position graph, does that mean that it's moving away from the sensor?
Ask the question one again.
If the position graph has a negative displacement, does that mean that it's moving away from the sensor
Other way around.
towards the sensor?
Displacement negative means we end up close. So it means x final is smaller than x initial. We're going toward the detector. How do we go toward the detector? Zero acceleration. What does that look like?
Like the velocity graph would just be a straight line. So it just be.
Is it helpful to draw a little velocity graph on the side? Velocity graph that is, and I'm just going to be picky about language here. When you say straight line, I think you're saying horizontal. Yeah. So it would be a horizontal negative. Yeah. So what's that position graph going to be?
So wouldn't it be going no acceleration would be just linear.
Oh, we won that velocity graph with positive displacement acceleration is 0. Aaron.
I have a question.
Yeah.
Is the acceleration the slope of the position graph?
No. The acceleration is the slope of the velocity.
Oh, right.
In our final minutes, we get a velocity graph with positive displacement and 0 acceleration. Yes! We have a winner! Well done. Okay, so for your homework, here's what I'd like you to do. I would like you to basically spend an hour. You may spend an hour, you can distribute your time as you choose between flashcards and text problems, but I'd like you to spend an hour on physics. I will put that up on Schoology, probably like over the weekend, whatever, but again, but yeah, I would just like you to spend an hour on physics, and be prepared for a small quiz.
Oh,
Yeah.
okay.